Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay, now comes this question. It says, write the name and the structure formula of the functional group. This must be emphasized. We want the name and the structure formula of the functional group of each of the homologous series below. Okay, the first one is alkane. What is the formula and the name of the functional group of alkane? Actually, alkanes, the functional group, are single bonds between carbon atoms. Okay, this is what we have. You have a carbon atom and another carbon atom. That one is what we call the functional group. So what do we call it? Single bonds between carbon atoms. Okay, then comes the next one. What is it? Alkenes. What is the structure, the structure formula of the functional group of alkenes? Alkenes, their functional group is a double bond between carbon atoms. So let us put it down. Double bond between carbon atoms. Okay, next one is alkynes. Okay. Yes. What is the structure formula of the functional group? It is a triple bond between carbon atoms. So it is a triple bond between carbon atoms. Okay, there's something I want to tell you here, that whatever carbon you put into an organic molecule, it must exercise a covalency of 4. I don't want you to fall into that trap. Every carbon must be surrounded by four outlets. That's the covalence of 4. So when you look at here, this one has 1, 2, 3, 4. This one has 1, 2, 3, 4. This one has 1, 2, 3, 4. Yeah, next one is haloalkanes. We must also remember that haloalkanes can also be called alkyl halides. Okay, so there we are. What are their structure formula of the functional group? So it is a carbon atom attached to a halogen. That's the structure formula of the functional group. where X represents Florence could bring iodine. Okay, yes, these atoms you see here, these elements you see here, they belong to group 7. Group 7 are given a name halogens. So these ones are halogens. That's why the name comes from halo. So when a halogen atom attacks here, the organic molecule which comes out is alkyl halide or haloalkane. Yes. Then comes alcohols. What is the structural formula of the functional group of alcohols? Okay, alcohols, the functional group is the hydroxyl group attached to a saturated carbon atoms. Okay, that's it. Hydroxyl group attached to a saturated or saturated carbon. Next is aldehyde. Yes, what is the structural formula of the aldehyde? It is a carbon atom attached to oxygen by a double bond. We call it a carbonyl. But at this side, there is hydrogen atom, and that's it. So what you see here is the functional group of aldehyde. The terminal carbonyl atom attached to hydrogen. And the name is formyl. That's the name of the functional group. Now, next, ketones. What is the what is the structure of the functional group of ketones? Ketones have a carbonyl group as well, but its carbonyl group is not terminal, it's not at the end, it's between carbon atoms. So we write it like carbon, double bond. So that is it. And its name is carbonyl or carbonyl group. So that's the functional group of ketones. Yeah, next is carboxylic acid. So what is the functional group? What is the structural formula of the functional group of carboxylic acid? It is a carbon atom attached to oxygen by a double bond, so it's a carbonyl but attached to hydroxyl group. What you see there, it is the structural formula of the functional group of carboxylic acid, and its name is carboxyl group. That's the name of that functional group. Yeah, then lastly, esters. Yes, what is the structure formula of the functional group of esters? Okay, first of all, ester has a carbonyl also, but attached to oxygen, and also the side attached to. So in other words, this is what we call ester bond. and it is the functional group of the ester as a homologous series. So what do you call it? We call it ester link or ester bond. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences. Silver Bullet. See you next time. Don't forget to subscribe. Don't forget to like. We are simply the best. Trust us.